methodly operate something?
なんかオペレートってまあなんかタスクをdoing some task だよね。do some task, achieve some task, do carry out some task。まあいいや。で、あとはwhat is your opinion? ラなんとか I don't remember about your family. So.
Robot is machine or a mechanism which does repetitive tasks on its own or through some pre-programmed.
なんか今メカニズムしたよね。メカニズムってことはなんかフィジカルボディだよね。フィジカルボディがありますよと。はい。それからで do some task。ボディ。
repetitive task or
repetitive。repetitive。まあボディがあってタスクをするんだけど、まあこれはなんかメカニズムだよね。タスクをする to do this task what is required more。
プログラミング。
もちろんアクチュエーターセンサーシステムっていうのがアクチュエーターセンサーシステムっていうのがあってプラスプログラミングだよね。プログラムでone important point is this is the same mechanical body and the electrical actuations, but if we change the program, this robot can do various kind of tasks. This is one very important variety of tasks. Variety of tasks it can do. When we implement the new program by using the same body, it can move differently and achieve the different task. It's one thing, one important thing. So it is a very different point compared to some special machine or special robot, special automation system. Automation. For example,例えば IC チップボードマウンターチップマウンター is do that it can do only one single task でなんか grasp the chip and the insert to the electrical board so this work is only specially designed for this purpose single purpose だからスペシャルオートメーションマシンはシングルタスクだよねOnly single task. So therefore, the variety of task and the single task, specific task purpose is very different, and this is a very important feature of the robot. And so therefore, the last week, I explained about the example of on the movement machine. Especially focus on the movement in special environment. で、例えばなんだ、マーズロボットはなんかサンディングコンディションとかで、and this is not hard. The standing condition is not good for the only single wheel. So therefore the special mechanism is developed. And also the another uneven rough torrent. The many kind of mechanism has been developed, like the battlefield robot, some special purpose robot is also the developed like this. The fin swinging robot is also developed to move in any rough terrain. And I said the four-wheel drive is good for the movement, for the faster speeding up of the movement. The four-wheel drive is stable and it's good for the speeding up for the movement, as I said. But the human being has two legs, and other horses or other animals has four legs, like this. So the human being is four leg becomes two arms, of course. So therefore, standing up, and then it becomes the manipulating arm. It's okay. But when we climb up the ladder, we also use arms to move. Ladder, ne? We also use two arms. For example, the wheel. Wheel is only disc-shaped wheel, like this. 5 people found how to found the people found this wheel, because in many cases the artificial object is firstly based on the living creatures, but the living creature has no wheel mechanism presently. Why we found this wheel? How to find this wheel? Disc shaped something we don't have.
Yes, I think the origin of wheels is that we make them so we could carry stuff faster.
Yes. This kind of disc-shaped object is good to wheel, and also some shaft added to the two things. That it is good for the carrying out the heavy load, for example. So therefore, we have used. But what found this kind of circular object and something. This is my imagination, but the imagination is some kind of slopes, and then the fence, some rocks is rotating. This rock is not only the disc shape, but some kind of shape is there, and it is rolling down along the slope. But this object is rotating around these lines, So therefore, some object. And maybe firstly this is some kind of object, and then it is rotating. It is not to the disc shape, but some kind of the cube shape or something, but the shafted inserted here, and then it is good. They found, but also they found that only this circular line is important for this purpose. So therefore the braked and only this kind of the cylinder shape is important for this purpose, so they found the disc shaped, maybe. So therefore, firstly, natural phenomena the human being is watched, and then experienced, and inspired from that, they found this kind of thing is very important. Wheel-shaped object is important for the movement. But bio-inspired or living creatures inspired thing is firstly be inspired is one thing, and also the natural phenomena, natural event watching based on this living creatures, natural, physical something, physics. We are creating from this inspired creation. So that kind of, so the people is thinking, so the robotics engineers, robotics researchers or engineers is the, especially if in especially about the movement, we think なんか例えばロボットデザイナーね、ロボットデザイナー How to design the robot for the movement?
Analyzing facts first.
そうだよね。So analyze. What you will analyze? Analyze. はい。
The task first.
そうだよね。だからタスク。What is a movement? When it is a movement is a task. What you will analyze?
If we need to carry out the heavy load, so we need to have 4 wheels. But when we need to make it climbing, so I think the swing one is the perfect one.
So the movement is also various kind of movements is there. So therefore the which kind of important thing is condition. Which kind of condition this task is? Under which kind of condition? So therefore you can find some requirement. Analyze, and you should analyze and extract some conditions, and based on this condition, what is the requirement for the movement mechanism? Then you will decide which kind of mechanism is good for this purpose of movement. Through this process, we will inspire from some of もちろん previous references and also the newly sometimes it's living creatures inspired or natural phenomena inspired or something. And then we will decide which kind of mechanism is good for this movement purpose, movement task. But also the human being's mechanism is good. 2 legs and 2 arms is good for various kind of tasks. So therefore, in many cases, many tasks the human being can do. Various tasks human being can do. So therefore, firstly, watching the human's operation. Firstly, for example, to do some task. Robot is mainly firstly used as reducing the human operators load, workload reduction, or the automation replaced to the human operator. So therefore, firstly, the human's operation we should watch and we should analyze. and then how to imitate this kind of movement, and then the robot designer designs the mechanism. This is also one process for automation or robotization. And so therefore the last week's subject is まあなんかspecial purpose special environment robot. まあ not only movement but the special environment special task is there. で in that case how to design maybe you can find various conditions and various linkage some condition and requirement and the robot mechanism. Maybe you may be able to find many examples relationship between the task and the task's condition, task's requirement, and then the which kind of mechanism that robot designer decided. So various kind of examples you can find. That is the main point of the last week's subject. And then if possible, you should compare with a human task or some other living creatures, 4-leg living creature or 8-leg insect. Or multiple legs insect or snakes and the other living creatures movement. That is my purpose for the last week's subject. Okay. これはラストウィークの話ね。Next これ。今日の Today's Exercise の話ね。Today's Exercise はこれもインダストリアルロボットとウェルフェアロボットでしょ。で例えばウェルフェアとかなんかリハビリテーションロボットとかメディカルロボットとかデイリーライフサポートとかはいでインダストリアルロボットのなんかスペシャルポイントなんですよね。インダストリアルロボットのなんかスペシャルポイントウェルフェアロボットのなんかスペシャルポイントなんですかね。What is special point of industrial robot? 今なんて書いたの
Rigid and long work cycle.
これレジュアルインダストリアルロボットレジュアルってなんだっけ。リジットね、
And long working cycle.
サイクルタイムがロングなの、サイクルタイムがロング。What's the meaning of cycle time long?
They have to work continuously, so for long hours.
まあロングピリオドってことか。
Industrial robot has more power.
まあパワーかな。まあパワーは必要かもしれないね。もうパワフル。
And some professional.
まあ sometimes speed is also important to speeding up the manufacturing task, for example. はい。で、
welfare robots increases our quality of life.
まあもちろんデイリーサポートだから QOL だよね。はい。
The robot need to be precise precise in the task.
プレシジョンって
Accurate.
accurate for what? accurate for
Doing task.
doing task? なんかでもデイリーサポートはプレシジョンといえばインダストリアルロボットの方が more precisely assembling or precisely inserting or precisely movement is required in many cases まあだからプレシジョンっていえばまあ多分プレシジョンは、インダストリアルロボットの方が more important
Industrial robots are used to automate manufacturing process almost without human touch.
オートメーション、まあ、パーパスイズオートメーションとかね、まあ、インダストリアルロボットはね。何やか。あとは
Welfare robot needs to be lightweight.
まあ、ライトウェイトか、ソフトとかね、だったりね。
Welfare robot may should be communicate with humans.
まあ、コミュニケーションか。まあ、コミュニケーションね。コミュニケーションか。
I think most welfare robots are humanoids
ヒューマノイドがベタ
because they could perform tasks that only humans could perform.
まあこっちの方がまあ presently the human being is doing so it looks like the human being is and also task itself is also the doing the human's task maybe human task replacement human task support あと何ですかね
The durability of the industrial robots may be better than the durability.
ability
Durability.
durability ね
Yes.
まあデュラブルっていう時にどういう意味かしたいんだけどまあデュラブルでもこっちもデュラブルはちょっと必要だけどなじゃあさまあちょっとコンディションってどうですかワーキングコンディションっていうのはコンディションとかリクワイアメントインダストリアルロボットのリクワイアメントウェルフェアロボットリクワイアメントサラウンディングコンディションとかリクワイアメント
Industrial robot is used in some environment for the manufacturing.
だからマニファクチャーのリプレイスメントまあオートメーションだからまあニューファクチャーかマニファクチャーリングのリプレイスメントね
Both industrial and welfare robots should be flexible to carry out various tasks.
まあフレキシビリティはもちろん重要ですねデュラブルフレキシブルジョンがフレキシブルまあいいやはい
Industrial robots are fixed, but most welfare robots have the ability to move.
まあムーブメントファンクションがいるとかいらないとかねムーブメントまあモーバイルロボットもあるんだけどまあこっちの方がまあこっちもムーブメントもいるなはい コンディションといったときに、when I say the condition, one important condition is industrial robot is powerful and very high speed movement. So therefore, basically, the industrial robot is separated from the human operators. Some safeguard fences is required, and also only inside of this safeguard, the industrial robot can work. But to the welfare robot, the target object is a human being itself. So therefore, the very closed condition near to the human being. Close to the human being is one important point. So close to the human being, yes, both need the safety functions, of course. But to the close to the human being, so therefore the safety directly to the human customer is important for the welfare robot. だから human existence っていう意味では、インダストリアルロボットは separated. But the welfare robot は coexisting. Basically. で human being. So therefore yes, both safety function is necessary, but to the safety fence, safety to the separated from the operator. So therefore, this kind of safety technology is necessary. But coexisting safety technology is more important for the welfare robot. これユーザーズビューポイントね。ユーザーズビューポイントなんだけど、ユーザー。例えばオペレーまあユーザーと似てるかもね。オペレーター、what is the operator of the robot? Industrial robot case, welfare robot's case. Operator. Maybe the industrial robot operator is basically the engineer or the human worker is some specialist is operating the industrial robot. But to the welfare robot, it's the mainly common people. Common users, generally public users, is a customer of the welfare robot. So therefore, the easy to use or the foolproof function is necessary for the general customers, general publics. だからなんかカスタマーuser is a little bit different とか、essentially different. で、skilled worker or the non-skilled user. But for example, the welfare and welfare industrial robot. じゃあ、あとここにコンシューマープロダクト、プロダクツっていうの as a product, industrial robot as a product, welfare robot as a product. What is the difference? Just for example, number of customers.
The cost is right.
Maybe the industrial robot is many 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 factories, many corporations, many factories. So therefore, if you product one industrial robot, the customer is estimating customer is a little bit large. But to the welfare robot, the one important point is welfare robot to the customer is not so large, because for rehabilitation robot or some daily supporting robot,例えば handicapped people, the condition of handicapped people is very different among individuals. How to support this one customer, specific customer, customer A, customer B, customer C, that is a little bit different. So therefore, some kind of customization is required. And some necessary function is also sometimes a little different. Functions. It means, なんかさ、industrial robots customer is まあなんか something like this. ね? But the welfare robots customers is in some specific demand is there. もっと低くてもいいんだけど。なんか、まあこんな感じ。例えばこれが needs、demand、needs とかあったらね。ある some robots needs。これがなんか number of needs、number of customers。そしたら、まあ needs is looks like this。But special welfare robot, special daily support robot is required by some people. The requirement needs is very high because this supporting tool is necessary for his life, his daily life, for example. For example, the one wheelchair or the artificial arm, artificial limb is required for that purpose, that customer. But the number of products requirement is limited. So the need is high, demand is very, very high. But the number of products necessary for that purpose is limited. And because the only single product can adapt to the one single requirement. So some kind of tuning up, customization is also there, but it is not so wide. Requirement is so high, but if it has another requirement, it is also another this kind of graph. This kind of another requirement. Then looks like this: product A, product B, product C. So it has other customers. But each customer's requirement is so high. So therefore, this kind of product is the customized or user adaptability is very important. adjustment for the each customer is important. But one industrial robot, yes, this is one industrial robot. One industrial robot can adapt to the various factories, various lines. So therefore, the number of products is also wide, and one product can cover various tasks, various customers' requirements. Which makes, based on this fact, what happens? What happens? Expensive. So the welfare robot become expensive. Number of customers makes a lower cost. Cost reduced. Because this has become the mass production system, the one industrial robot can become the mass production product. But the welfare robot is only the limited number of market. Market is limited, but the requirement is so high. It means the product is become expensive. So I ask you to think in this exercise. でした。それでもうこんな時間ですね。もうこんな時間ですね。はい、いいですか ?OK。ちょっとだからなんかさ、こっちとsimilar to this talk. I said the condition, requirement and robot itself. Requirement robot relationship is important. So this is similar to this industrial robot requirement, welfare robot requirement, and which kind of robot we should design is a similar framework. But the price, cost is depending on the number of product, the number of people, customer it has, that product has. If the limited customer is limited number of customer, the product become expensive. The more wider range of the customer, it will become the mass production system, mass products. So therefore, the cost is reduced and the product become not so expensive. はい、です。同じようなことですね。はい。今日の話はちょっとじゃあいきましょうね。Dependability の話ですね。Okay. So let's move on to the today's part. Dependability っていうのは What is the dependability? Include 書いてあるんですね。なんか System performance, availability, and the factor to affect the dependability is reliability, maintainability, and maintenance support. So these four factors is included in the dependability. No repair system is irreparable. Irreparable means cannot repair, and once it is break down, once it is failed, it is not to be repaired. So therefore, the dependability is mainly to the time to failure. And the repair system is when some trouble is happened, we can repair. So the maintainability is also important. How to recover it. is important. ここら辺は this kind of is some definition, so therefore the reliability, maintainability is defined like this. And also the availability, failure rate is defined like this. Okay. In case of the robot dependability, the various factors is there, so because the various technologies, techniques is included in one system, integrated into one system, so therefore the mechanical factors trouble, electrical factors trouble, program factors problem, or various kind of factors is there in troubles. That is not the good point. But the good point is the sensor is also used in the mechatronics system. So therefore, we can watch anytime any conditions. When the failure happens, the condition we can track back by using the sensory data. Failure of the industrial is very damage to the productivity and manufacturing system. So, and also the serious problem from the viewpoint of the ensuring the safety, because in the teaching task, in teaching to the robot, the human worker has to be close to the robot, and the welfare robot, medical robot's case, the coexistence with a human worker, human user ですね。So we should reduce and cope with the failures. We should reduce the case of the failures. Failures type is causality is easy to find, not good to, but the most serious problem is for example the software's bug. Software bug, because the software bug is happened only under some conditions, special conditions. But sometimes it is very difficult to find that kind of condition. Which kind of condition? Some program is not good working. We cannot find easily. So therefore the software's problem is very serious. Occurs sometimes. And the restore after file. But it doesn't repeat. So we cannot find which kind of condition makes this kind of failure. We cannot find it easily. So therefore the software bug is very, very serious problem. The error history should be recorded. So therefore the error history should be recorded. The flight recorder or driving recorder is presently usually used. And for example, for the industrial robots case, motor currency is usually monitored and destroyed its data. Useful not only for failure of robot, but also the faulty parts to assemble and analyze a failed task. For example, the product lifetime, we can estimate some parts condition, parts weakness condition. わかるよね。プロダクトのライフタイムですね。We should estimate. So for example, the moving parts, some bearing should be replaced in some period. So therefore, the fan we should replace this bearing, or insert additional oil, additional grease to the moving part is also necessary in some case. So fan we should do this kind of maintenance task is estimated based on these data. で、もちろん working time is one important part, but it is depending also on the workload weight. で、one important analysis method is FTA, fault tree analysis. Fault tree analysis is main fault is extended logically to its causality using the tree-structure chart. The top event is some failure. This failure is divided into the several preliminary events, primary events. This primary event is divided into the secondary events. And the secondary event is divided into some fundamental events. So we should find such is fundamental events to cause this top failure. And this is a fault tree analysis. Main fault is one top, and it is logically, some factors is logically connected by and or functions. It is and or function ね。で、だからイベント、ファンダメンタルイベント A とファンダメンタルイベント B の if it is event is happened, this secondary event happens. This secondary event and another fundamental event is the A or B, either of them is happened, this primary event happens. And this primary event is a cause of this main failure. わかります？これは一番重要な today's one important point for today's subject. これですね。fault tree analysis は例えば for example this wind farm. This wind farm's the rotating part is failed. Why this rotating part is failed? Because the one is a weakness of the material, or the rotational movement is a very dangerous or unusual rotation is made. Why this unusual rotation is happened? Because of the control system is failed, the electrical power source is failed, or the electrical circuit is shorted. Some failure factors is listed up. And then why the power source failed is happened, why this controller failure is happened, we should estimate. We should divide into several events, several factors. By doing this, we can estimate the possibility of this kind of failure happens. ということで、ちょっとこのビデオを見ましょう。We will watch this video.
Welcome to this NIBOS Diploma question and answer session from Safety Management Consultancy Limited. I'm Steve, one of the health and safety consultants, and I'm going to take you through the questions and answers. Okay, let's take a quick look at a question. The question relates to a fault tree.
ちょっとこれ、you should do. Okay. ちょっと見ながら、while watching, you should do.
And the question is worth 10 marks, and it reads, an operator is required to monitor a steam boiler. Under fault conditions, the operator is at risk from injury from explosion due to either of these conditions. A, the boiler burner being lit when operating with low water conditions, or B, overpressure.
B、この this example はなんだスティームボイラーのメンテナンスしますよ、ね、スティームボイラーのなんかオペレーターがいますよでスティームボイラーのフェイラーはボイラーバーナー being lit when operating with low water conditions っていうのとオーバープレッシャーだからwhen the operator's injury is A case B case ねA ケース B ケースでここのテーブルは A ケースのファクターはこういうファクターがあります A ケースはこういうファクターがあります B ケースの時はファクターこの3ファクターズというのを今話をします
Expected frequencies of the failures that would lead to either of these effects are given in the table below.
ここにフリーケンシーがそのフェイラータイプ、ここのイベント A、イベントプライマリーイベント A、プライマリーイベント B のファクターがここにあって、このファクターの how much frequently it happens で it says
And they are for A, the boiler burner being lit, is the water level detector fails at a frequency of 0.1 per year, or
1.5
an electrical fault at a frequency of 0.05 per year. For
0.05
B,
B,
the overpressure, there are three conditions here. Is the electrical fault, again at 0.05 per year, the pressure switch failure at 0.1 per year, and the relief valve failure at 0.05 per year. Given that the operator is at risk for 20% of the time that the boiler is operating, you have to construct and quantify a simple fault tree to show the expected frequency of the top event, which is the injury to the operator. Please press pause if you'd like to have a go at this question.
ということで、今言ったの分かったかな？というかボイラー、フェイラーね。ボイラーのフェイラー、ボイラー、フェイラー、ボイラー、スティームボイラーのフェイラーで、スティームボイラーのフェイラーで、オペレーターがいますよと。オペレーターがこのスティームボイラーのフェイラーでインジャードしますよ。で、スティームボイラーのフェイラーは A ケースがローアウォーターでフェイルする場合と B はオーバープレッシャーでフェイルする場合がありますよ。スティームボイラーのフェイラーは2 cases だよ。で、A はそこに書いてある2 factors でローワーウォーターレベルね。それからオーバープレッシャーは3ファクターでオーバープレッシャーになりますよと書いてあります。で、そこに。で、このスティームボイラーがフェイラーするんだけど、オペレーターは、ワーキングアワーの 20% ワーキングアワー is the bear というか、これが、ここにオペレーター is risk for 20% of the time the boiler is operating って書いたんで、それはnot wearing the safeguard is a 20% the time とか、ね、例えば。ということで、please draw fault tree in this case。ちょっとだからトップイベントは何ですかって言ったら、このオペレーターインジャーは何とかの場合と何とかの場合になった時にオペレーターインジャーするんだけど、でスティームボイラーのフェイラーはA ケースと B ケースがあって、A ケースは2ファクターがあって B ケースは3ファクターがありますよっていうことなんだけど、 Please write the fault tree。 Your pages, your note, in your note, please write fault tree case of this case。3分もいらない ?3 minutes. You should write down this. And if possible, you should calculate the operator injury possibility per year. The data is shown, frequency is shown like this. In these factors, how frequently this factor happens, it shows. So therefore, by using the and or functions, you can estimate how much possibility this operator has to become injured. A case, B case があって、A ケースは2 factors ビッグケースは3 factors ね、で how frequently these factors happen is shown in this table. So by using this table, you can calculate how frequently how possibility the operator injured accident happens per year. これは YouTube に載ってるから別に You can find later this video. 何か書いたかな、書きたくみたいな、そういうやつを書いて、なんかこのフリーケンシーをちょっとカリキュレーションしましょうって話ですよ。そうだよ、そう。テーブルだけでそうなんだけどさ。そうなんだけどさ。答えを見る前にちょっと、やってほしいな。一応自分で考えてほしいなっていうのが。はい。では続きを見ましょう。We will watch.
Okay, let's look to see if we can construct a fault tree for this question. Well, the first thing we need to do is identify the top event, which is the operator being injured. Now, how can the operator be injured? Well, let's look at the events below that then, which are the first level events. Now, how can the operator be injured? Well, we know that it's due to the boiler explosion, but also we need the operator to be exposed. Now, we need both of those conditions to happen. So we need the operator to be exposed and we need the boiler explosion. And because of that, then that is an AND gate. Next, we need to look down at the events below the boiler explosion to the second level events. So we were given them from the question, and that was either it was due to the water condition A or overpressure, which was condition B. But the boiler could explode due to either of these. So for this, we had to have an OR gate because it could either be low water or the overpressure. For the third level events then, well, we were given them again in the question from the table. That is due to the load detector failure or an electrical fault or condition low water. So that is an OR gate because again it is either the level detective failure or an electrical fault. For the overpressure condition B, there's actually 3 conditions. It could be due to the electrical fault or the pressure switch or the relief valve. Again, either of these, that is also an OR gate. So that is what your fault tree should look like. I think that the main thing to remember here is to make sure that you have the operator exposed.
How many frequently it happens?
Sorry, the first level event. Okay, what we need to do now is apply the frequencies from the table. So for condition A, the low water failure, well, the frequency for the level detector is 0.1 per year, and the frequency for the electrical fault 0.05 per year. And because this is an OR gate, we need to add the frequencies. So to get the frequency for the low water failure, that is 0.1 plus 0.5, giving us a frequency of 0.15 per year. Again, for condition B, applying the
プラス
frequencies to
サマ
how
ライ
the
ズね。
overpressure
These factors
happen.
サマリー
And
が
for the electrical
or
fault, 0.05 per year. For the
こ
pressure
っちもこっち
switch,
もこっちも
0.1 per year.
だから
And
これ
again,
も
for
フ
the
ァク
leak
ター
fault,
が
0.05
How
per year.
much frequently, how much
And
frequently,
again,
how
because
much
this is an
frequently
OR
で
gate, we add the
So
frequency
therefore
so we
the
get the frequency of
overpressure
the
condition
overpressure
は
is
happens
0.1
all of
plus
this
0.05 plus
Summary.
0.05, giving us a frequency of 0.2
So therefore
per
the
year.
0.2 times per year.
Now to get the frequency for the boiler explosion,
So boiler
then again that
explosion は
is the frequency of the low
case
water
A or case B だ
plus
から
the frequency
これの
of the
プラス
overpressure, and therefore the
Summary.
frequency is
Summarize.
0.15 plus 0.2, giving us a frequency of 0.35 per year. So now we have the frequency of the
で
boiler explosion.
even the boiler is
But from the
exploded.
question we were told that the operator
If
was
the operator
exposed
is
for
protected, it's
20%
okay,
of
but
the time.
20%
So
time
the
is
frequency for the operator being
close to
exposed
the boiler.
is equal to 0.2 per
Okay.
year, equating
So
to
the
20% of the time. Now to
So
get the
therefore
frequency
that
for
this
the
is
operator
and.
injury,
And
we
is
have an AND gate here, so
multiplies.
rather than adding them,
Multiply.
for an AND gate
Times.
we times the frequency to get the frequency of the operator injury. So the frequency is 0.2
So therefore
times
the possibility of the
giving us a
operator
frequency of
injured is
0.07
this
per year.
0.35 and 0.2. The
So to give you marks for this question, you need to draw a full tree that looks something like that, and calculate all the frequencies at each of the level events, and calculate the frequency of the operator injury at 0.07 per year.
というわけでした。OK。わかりましたやり方は。はい。というのが、フォールトリーアナリシスね。でもう12時過ぎちゃったから、もうやめますけど、で、カウンターメジャーか。カウンターメジャーは、フェイラープリベンションをするってことと、ルールっていうのがまあ一つのカウンターメジャーですよと書いてある。でそれはどう設計しましたかというのがまあここに書いてあって、どんなことがありますかとかここに書いてあるんですけど、まあ例えばだからハザードがあって、人とヒューマンロボット攻撃システムのハザードが、ヒューマンハザードはどんな時になんかコンディションでオアのがこうあって、それのポッシビリティとか、を考えると、this kind of hazard is happened how much frequently you can estimate 感じですね。ということです。というようなことで、まあロボットリライアビリティとかロボットディペンダビリティとかロボットトラストのビデオがあるので、if you have some time you should watch. And also this book, Robot Reliability and Safety, the Springer's book, you can access freely from inside Waseda University. So that if you are interested in, it contains many chapters related to the robot reliability and robot safety. You can find it. Okay. でちょっとこの今日の Today's second part の Human Error は I will skip.